1/2. So this is also, oh sorry, one half. And then the one here is exactly so here the slope is 2. The slope here is 1/2. These two slopes are reciprocal each other. Because f is, yes, fx is x squared. Here x, the values of x are restricted to 0 and between 0 and 2, inclusively. So the inverse of f will be the square root of x, and x between the 0 and 4 inclusively. Therefore, f prime of x is 2x. F inverse prime means the derivative, the square root function, is this one. Oh. The last example. Okay, for this, the inverse of f at 1. So we want to find f inverse of 1. F inverse of 1 means okay, so wait a minute, 1 or 2. Oh, yes, you're right. If this is some number, that means f of this number will be 1. Okay. If the value of this function is 1, x will be 0. Okay. By inspection, when x is 0, then this is 0. Cosine 0 is 1. Of course, maybe we should check this function is a one-to-one function by check its derivative. But sin x at most 1. So this function is increasing on the entire real number line. Therefore, f is 1 to 1. Increase or decreasing functions are 1-1 functions. Okay, so by inspection, if we want to find the value of this function is 1, it should be 0. 0 cosine 0 is 1. Since f0 is 1, f inverse 1, f inverse cancel is 0. So in order to obtain this one, we need to find the derivative of f at 0. F prime at 0 is 2 minus sine 0. Sine 0 is 0. This is 2. Therefore, f prime at f inverse, the derivative of the inverse of f at 1 is the reciprocal of f prime at 0 at the corresponding position. 1/2. Okay? This one and this one reciprocal to each other, 互为导数和造数。If you use the lousy formula, f prime at, but f inverse 1 is 0. Anyway, if the function f maps 0 to the number 1, the f inverse maps 1 back to 0. So in order to find the rate of change of this function 1, we need to find the rate of change of f at 0, because these two rates of change are reciprocal to each other. Okay, so this end of section 6.1, 6.1. Next, we will move to 6.2 star, not 6.2. Section 6.2 star. There are three authors. The authors wrote, introduced the natural logarithmic function and the natural exponential function in two ways, two approaches. One for maybe just application, another one for is theoretical approach. Another one is use examples approach. We choose theoretical approach. The natural logarithmic function, 自然对数. Okay, the motivation is that use this formula when we find the indefinite integral of this power function. We use power rule. Simply by adding 1 to its exponent and divided by this exponent plus c. But you should know the denominator cannot be 0. This means that you can integrate this one. This will be x cubed over 3 plus c. You can integrate this one. The result is x squared over 2 plus c. You can also integrate the constant function. Regard R be 0. Then 0 plus 1, 0 plus 1. Of course, you can integrate this one, okay. Use power rule. This is exactly minus 1 over x plus c. And then this one is x raised to the minus third. Again, I use a power rule. Increase this exponent by 1, x. So minus 2 and minus 2 are cancelled. But what is this? You cannot write, oh, x minus 1 plus 1 divided by minus 1 plus 1 plus c and obtain. No. No. this is not right. Yes, there's a gap here. Moreover, we can, from now on, not from now on, until now, we can only study or talk about the exponent, which is a rational number. Rational number. How about the exponent is an irrational number? Okay. So in this section and next few sections, we will solve these problems, all these problems. Okay, take a short break. We will solve this problem first. Find the antiderivative of this integrand.
Bài học rồi. Mỗi lần đều lên hỏi luôn. Tinh thần học tập. Trường Khang cũng chăm chỉ rồi. Lúc mà đang giảng, lúc mà làm bài tập nó không chép nó sẽ giảng.
Đây không có đứa nào tới lúc
Còn tới tiền tao nói rồi. Tao nói là sợ.